Next, we'll look at negating nested quantifiers. We have previously used De Morgan's laws for quantifiers to negate single quantifiers. Here, we'll do the same thing successively. And if we have the negation of, for all x, there exists y, and then in parentheses, the compound statement p of x and q of x, in order to negate that, the first thing we'll do is we'll apply the negation to the for all. So the for all will become there exists x. The negation will then move through to the there exists y. And the rest at this point remains unchanged. And notice each time I'll just write what's changing in red. So now I'll go back to blue for the there exists x because it's already been applied. It's not having anything applied yet at this point in time. The negation is going to apply to the there exists y this time. So the there exists y will flip and become for all y. The negation will pass to the parentheses, and inside the parentheses is, as of yet, unchanged. So we're just applying this one step at a time. Next, the negation needs to apply to the parentheses. And as we looked at previously with the other De Morgan's laws, when we apply this to the parentheses, it applies to each one of the terms inside, and the and will flip and become an or. So there exists x remains unchanged. For all y, already been applied, remains unchanged. There's no more negation outside of the parentheses. It moves inside, and we've got p of x is negated, and we've got q of x is negated, and then the and becomes an or. And I should have written that in red, and that in red, and the or in red. There we go. Now showing which was affected.
Onto the individual variables, stops at the function.
The negation is completely passed through. You cannot apply the negation any further than the propositional function. It never goes down to the individual variables. Stops at the function.